So the first sort of question is, what do you mean by enterprise? It's a very overloaded word. And so I want to discuss a little bit about that. And enterprise, in a sense, means complex, it means large. There's complex requirements. There's often competing, conflicting requirements, because the bigger a system gets, the more stakeholders it has, the more a business process it's trying to automate, the more there's deviations and changes and weird things that happen. So when you look at a large software system, it's often not a single system for a single user group, but really a system for multiple user groups, and those user groups can have very different requirements. So it has to be configurable. In the bad old days, that was all through custom code, which is why you had $200 million ERP implementations. Systems have gotten more configurable where you don't have to do that. It's got to be long-lived because it's got to support some complex needs for a long time because there's a large investment in anything. So if it's an enterprise system, it means it's big, it's large, it's complex, and it's expensive, so it has to last longer. And it has to work across multiple systems, so usually there's integration points to other systems as well. So I'm not sure how, there we go. This is the zone right here. So the enterprise considerations, what do you need in an enterprise system? It has to be adaptable, it has to have longevity, it has to have scalability, it's got to be accessible to different users, it's got to be of high quality. And large companies building large systems, enterprises building enterprise software have certain concerns. They're concerned about support, about consistency, about staffing. They're also concerned about making mistakes. This has a huge impact on technology and on frameworks like Angular. When something gets adopted as sort of the go-to technology, it needs to satisfy these constraints. And once that happens, it creates a lot of energy around something. It shifts the ecosystem, and these things become more important. And with large organizations, some of the things that drive the selection of technology they're driven by a consensus. It has to satisfy a lot of different stakeholders. It's driven by central teams, like an architectural organization. It's driven by competition. They need to be able to compete with their sort of other people in their market. So there's a huge shift towards Angular and financial services because there's been some really amazing user experiences created by some banks, and that's causing everyone to look at their front end, and they need to support mobile, and they need to support an excellent user experience. And that's driving the adoption of new technology faster in certain markets. And they're driven by technology adoption life cycles. So nobody wants to use something if it's going to go away in 2 years, if it has to live for 10 years. And so these are all key considerations in terms of Angular as an enterprise solution. And it affects the answer to the question of, should we use Angular? There's a couple of reasons you'd want to use the technology. It's fast to market, it's a great framework, you can get the experience for your users that you want. And if you're a small company, you can pick any technology you want, but you want it to have at least some level of safety that you're making the right choice. As you get bigger, that becomes more and more important. And so if you're sort of, say, sitting on the fence and thinking about adopting Angular, you can consider what's happening in other parts of the market as well. And what's going to be driving the adoption and the long-term health of Angular is that it's going to become very entrenched across all kinds of different software ecosystems. I used to do Ruby on Rails development, and Rails, when it came out, it was very interesting in that it replaced certain niches. It replaced the Perl development, it replaced the Python development, it replaced some of the Java development that startups were doing if they hadn't moved to Perl or Python. It did not replace the Java development. It did not replace the .NET developers. Angular is different. I used to compare Angular a lot to Rails, and I'm going to do that a bit today. But Angular is different in the sense that it's being used by everybody. It's being used by banks, it's being used by .NET shops, it's being used by startups. And so there's going to be a lot of these organizations influencing the long-term sort of health of Angular, and it also reflects their perception of that. So they've done their review of the market, and they've picked Angular for some of these reasons. So why is Angular enterprise friendly? In a sense, Angular, this is going to upset a lot of people, but AngularJS is the Java of the front end. It's in for the long haul. It's a safe choice. I know a lot of people are going to be depressed and they're going to go to the Backbone meetup next month because of the statement, but AngularJS is the Java of the front end. It's sort of filling that niche because there's a huge void there. We're moving our critical system engineering from the back end, where we're building these massive systems in Java. They're well engineered. We've got good design patterns. we're really thinking deeply about it. Where the ecosystem's been producing all kinds of great innovation. In Java you got Spring, Hibernate, inversion control, dependency injection. That's happening on the front end now, and there has to be a sort of consensus because there's a lot that goes into supporting something over the long haul. And it looks like Angular is taking that sort of position in the market. And it's going to be the go-to technology for a lot of front-end development, and it's going to be chosen in a lot of cases for that reason specifically. I have met, I'd say about half of the clients that I've met with have short-circuited their evaluation because they want the support of the ecosystem. Angular has the most books, the most videos, the most training now, and it's a lot easier to go with what other people are going with. And if startups are going with it, the startups will use them as a reference. If enterprises are going with it, the enterprises will use them as a reference. They don't cross-reference each other very much, right? This is a key concept in Crossing the Chasm by Jeffrey Moore, in that a market is a sort of group of people who are looking and buying the same thing, who reference each other. And your enterprise software choices are not really influenced by your startup software choices, but those two markets are both moved in the same direction and have independently sort of adopted Angular. Whereas the startup market could easily do a quick about face and pivot and pick another technology like React or some of the new interesting frameworks coming out. The enterprise sort of won't, because they have to make these decisions for the long term. And these projects have already kicked off in a lot of companies, and it's going to be a pretty dominant influence. And that's sort of where it's sort of filling that same role. So it's not Java in terms of being a loaded, sort of complex, sort of verbose language that drove people to adopt Ruby and Python and Perl and whatnot, and JavaScript. It's filling a void of being the go-to choice in large enterprises. It has an extremely strong ecosystem. It's got amazing support now for books, training, and all those kind of things. It's got strong sponsorship at Google in the open source community, and now you have these organizations that are using it internally, and that's going to influence the support as well. It's got a core of enterprise features. A lot of, we do a lot of training, and we find that often the Java developers understand Angular better than the front-end developers, because they've been working with dependency injection and modules and namespaces and all these concepts of larger scale software engineering. Angular is a whole framework, so it answers a lot of questions for you, so you can get rolling quickly and not have to piece together too many pieces, but it's still extensible. It plays well with other modules and other systems. So you get you get the benefits of it being a framework, but you can also mix and match pretty much whatever you want with it if you really need to go down that route. Some of the code features, Angular architecturally is pretty revolutionary. It decouples JavaScript, HTML, and CSS, so they do not get tangled up anymore. You can write applications where changing the JS doesn't force you to change the HTML, which in turn doesn't force you to change the your CSS. It's data-driven, which works very well for large-scale apps. It's comprehensive, and it plays nice with others. So, why will Angular win? Now, I put that in quotes because it's not a win, and there's lots of innovation going on, but Angular does work well with others, and there's that gapping void in terms of what is going to be used in a lot of companies that will have the right support and the right longevity for these large applications. And the question is, what wins in a rapidly changing world? Often it seems like there's so much innovation. A lot of people ask us, Angular just blew away Backbone in less than 2 years. What's going to take out Angular? Well, it's a question of what's happening culturally in all these different software ecosystems. It's going to affect that considerably, as I mentioned earlier. So it fills a significant void. It answers how to build a larger application in the browser. That's a new thing. Google had done it, Twitter had done it, but this is becoming new as the standard way of building apps, and you no longer have to have a sort of progressive enhancement and failback option. Like Google, with all its fancy features, did support older browsers initially. So, now you can just build an Angular app and you can go sort of full tilt, building a browser-based single-page application. There's no established competitor, right? So markets typically have competition, and you have a market leader, and they get a lot of traction because of that. That's why Windows is so popular. once you're there, you fill that space. Angular has unique differentiators, so there's a good reason to pick it. The data binding, data flow architecture, the way that it uses the view, the HTML is the view, and it has a significant amount of momentum. So, at this point, if people have to pick a framework, Angular is the first choice by default, and then people will step back and look for why maybe they should use something else. And I've worked with clients that have used Backbone and React for good reason. But in the general market, there's not a lot of compelling reasons, things that are going to slow down that momentum. There's also a lot of learning that goes on. So people have spent 2 years learning how to build Angular applications the right way. And that has a huge drag on new sort of frameworks that come out, because it takes a long time for them to actually become mature and how to build things the right way. Now, I might have a slide on this a little later, but I've talked about this a bit before. A case in point is when Rails came out, in any new technology, when it comes out, people mistake the framework for the architecture. And architecture has nothing to do with the framework. Architecture is the logical organization of your code. It's your modularity, it's your encapsulation, it's your levels of abstraction, it's your design patterns. But people mistake frameworks as providing architecture. And I remember once working in a large enterprise company where we were presenting this large enterprise Java application framework. And I talked about the architecture that had to be defined. And I got this stunned look from a manager, but we just bought your software, isn't that the architecture? And it's like, well, no, that's the foundation, but they were in a unique business with a unique domain model. They work differently than other companies, and they had to understand how that mapped onto the software and provide, a layer above. Angular's the same way. So early Angular projects, people looked at it, and it's like, okay, everything goes into the controller. Services, encapsulate some stuff, and that's how we build apps. As things have evolved, people realize what the mistakes are there. The controller should be skinny. That services should contain most of the logic. The practices of building directives. Early directives, or people's first directives, are basically sweeping all the ugly stuff in their HTML under the rug, but it doesn't actually have reusability or encapsulation or isolation or good software engineering principles. So these are the things that become really critical when you're trying to reuse things. Directives bleed horribly when you try to reuse them if they're doing something that's significant, unless you've really architected them effectively, because the corner cases will kill you. And that happens a lot when you use directives that wrap other libraries, where you start running into sort of challenges where it doesn't actually work the way you need it to work, and you end up ripping it out and writing your own directive that wraps some other library. Rails is really quite educational, and when it came out, the actual recommendation was fat controllers, skinny models. Actually, let me think about that. So basically fat controllers and skinny models, and no service or logic layer whatsoever. And then over time that inverted. So skinny controllers, fat models, and then people started introducing service layers, and then people started introducing design patterns. And 10 years later, the Rails world of building apps looks exactly like Java did 10 years ago. And then you have delegates, and you have facades, and you have all of these intermediaries, because these are the things that large-scale complex software problems require. And they show up sooner or later. And so, what are the evolutionary pressures on a software environment? And so, if large companies are using a framework, they're going to have certain demands and needs of it. They're going to make pull requests, they're going to make changes. Third-party libraries will pop up that solve some of those problems, and that will evolve that technology into the space of being able to handle large, complex applications. And so that's what's happening with Angular now, is that there's a lot of evolutionary pressure on it to be able to develop best practices and systems for building extremely large applications. And that's going to move it a few notches above other competing technologies, because they're not going to have that amount of investment in the wild, so to speak. The other thing is that you need your technology to be safe for 5 to 10 years. People would build applications, and they would be constrained by the browser, and they would do whatever they needed to do to get the browser to work. Horribly expensive, awful way to build applications. It was the only option, though, because you needed to use the web to distribute your applications. Now we're moving a lot of our server logic up into the front end, and so there's that risk of really this huge investment that's going into your front end, into your business logic that's going into the browser. And if you don't think about the longevity, for 5 to 10 years, you're just writing off a massive investment in expensive software. So what is practical enterprise AngularJS? That's sort of the theme. And how is it future-proof? How can you future-proof your choices? And what other things should you consider? Basic architectural considerations. So this is an interesting way of thinking about your Angular application and sort of how it looks to you when you read it. Angular is about 20% of your application architecture. If you think about what two-way data binding means, and using HTML as the view, that has a huge impact on your architecture. But what about your business logic, your business rules? What about your sort of services and the back-end communication? Those things they use some Angular services, but the vast majority of that code is, just really JavaScript code. And so that goes to my earlier point, don't confuse frameworks with architecture. And if you take this approach and you look at your software this way and you sort of, enthusiastically sort of use good software engineering practices to compose large-scale applications, you'll end up with an application sort of code base that sort of shows this. And so you have lots of JavaScript, sort of in the Java world where people moved away from Enterprise, J2EE, and started using sort of open source things and plain old Java objects. Now you have plain old JavaScript objects, and Angular works extremely well that way because it uses JSON as its incoming data format. A lot of the stuff that is Angular is really very lightweight. That's just there because it needs to be there. It's dependency injection, it's module system. All those can be easily replaced, and there's a lot of work making sure that will be the case in future versions. And so when you read your code, if everything looks like Angular and you're seeing Angular services sprinkled everywhere, you probably have the wrong application architecture. So most of the code should be services that look like plain JavaScript, largely. And to quote, the rule of thumb, code that can be written without referring to a controller scope should be written this way and should be placed in a service. That's here I'm quoting. Large-scale apps. So there was a talk at MDConf. This is one of the few data points on a very large-scale app in the public. The double-click application with 71,000 lines of JavaScript code, 20+ JavaScript engineers, 133,000 lines of unit test code, 26,000 lines of markup, and there's a breakup of controllers, directives, and services, and 1.7 megabytes of JavaScript as a single-page app. We've worked on apps that are about half that size, and we've done that as a single-page app without any real strong, compelling reason to split it up. What are the other? So when you start thinking about that, though, like, okay, we're talking about a large app. There's different modules. Should we do a single-page app, multiple single-page apps? How should we handle loading files, and should we use require.js? So my answer there is maybe. It has some ES6 alignment in terms of module. There's also browser file, which is very cool, and script.js. The thing to do is to really think about what you're trying to do here. And what's the goal of using a loading technology? So you want decoupling of code, so dependency injection. You want to be able to support testing. You may want to support asynchronous loading, so if you get very complex dependencies, you want to enforce modularity, and generally, you should solve for each of these as needed. And if you need to sort of, I guess if you're really concerned about this, look at what the impact is down the road, because this is an area where there's a lot of change going on in the JavaScript space. So if you can defer your decision, if you can back out of your choice, then that's a good architectural approach. Require.js is fairly complex to add. If you do need it, if you get it in place, it will work well. It will require some engineering sometimes for new modules. So to further decision, move in the direction of ES6 and Angular 2.0, try to make decisions reversible. And the default module, so the way Angular works is you basically have this massive index HTML file which is loading all of your modules. That's pretty easy to change because you've got everything in one place in a stupidly simple manner, which is one of the causes of the pain. If you start running into a lot of pain from that perspective, and you want to move that over to another way of managing dependencies, when you reach that sort of bridge, you can cross it fairly easily. If you go the other way, sometimes you might be stuck a little more. So single page apps versus multiple page apps, when to divide an Angular app into two. So some considerations are physical versus the logical division. Some people just have problems comprehending the scope of the app. There's so many pieces to the app, it seems easier to break it into two, but often that's really a question of what your component architecture is and how you're composing apps from reusable pieces. So if you need to move something into a reusable component and have that live in its own life cycle, then you can use things, Browserify would be one way of actually managing those dependencies, but because Node does that very well. But you can also manage that in your build process. So for instance, if you have something that's going to be a common authentication module, you can manage that in its own lifecycle in a Git repository, version it, and then you release that and use Bower and include that into your project. So you think of your app as you would a collection of open source modules. And that's one of the sort of failings of early applications. They start small, and by the time we realize the pain of all these different components and the interdependencies, it's, we're way down the road. Now if you over-engineer it, you're going to break things into modules that don't actually have their own unique lifecycle. But the idea is to aggressively look for that and really explore how you build your physical releases from your software components. And so aggressively use Bower and NPM and those tools to have a concept of what your logical software architecture is, and then use your build process to create your physical deployment of it. That has a huge impact on this consideration because you can now manage a very large code base and you can manage it with smaller components that have their own life cycle. You're not going to have to say every time someone makes a change to the authentication module, regression test everything in your whole app, because that can be tested independently and be approved independently and deployed independently. Network capability, so if you have a slow network, you may be concerned about the download times of the JavaScript. Generally with minification and large sort of source code bases, it's not a lot. Most of the time you can look at how much JavaScript you have minified and it equals 2 or 3 images that you might have in an app. It's not really a big deal. If it's going to be a mobile app, you can have it preloaded in the app. It's something you can optimize for and manage when it comes up. If you get really stuck on that, then you can start looking at some asynchronous loading, and you can do that conditionally. It's actually not that hard to write your own conditional asynchronous loaders for your own modules that you may want to do. The browser capabilities, so who you're targeting. Generally, browsers can handle pretty much what we can throw at them, and whether you're going to use async loading strategies to fix some of those problems. But the idea here is that you really solve a problem, you don't sort of pre-optimize. So stick with one app that implement components versus source control management, and your build process optimize when necessary. Web components, this comes up all the time. It's not a standard, it's not supported by browsers, it's far away, it's sort of unproven, it hasn't gone through the large-scale application sort of uses, and generally it's really hard to build a strategy around it, so we pretty much stick with Angular and directives. I think there will be interesting markets and ecosystems where web components will arrive earlier. But right now, your choice is Polymer, which runs largely on Chrome, and I'm actually not really sure why web components it's exciting, but it's still a long ways away, generally speaking. So I can't really find a good case for spending a lot of time worrying about it. It's sort of like, I think Angular 2.0 is taking into account some of the direction, understanding it, so you might shift some of your development to be future-proof, but to overthink that means you're going to be spending a lot of time possibly not optimizing your use of Angular and what's out there now. that's one of those difficult architectural decisions. So organizational considerations. So the other thing with Enterprise Angular is that you have a lot of developers who are working on it. And if you're jumping into Enterprise Angular, it means that you already have a large team, you have a large app, and you have to deal with these realities, now. If you're a startup, you're building an app, you don't really have the organizational considerations because you have 2 or 3 people, you can get them trained easily, you can hire for your technology needs. But on bigger projects with existing developers, this has a huge impact on how you approach adopting Angular. So one way of thinking of this is the middle-end developer, which I like because it doesn't make sense, but it's sort of your middle-tier developers. So you have back-end developers and front-end developers, and the back-end developers understand software engineering, dependency injection, and modules, and they can architect these really complex abstractions with facades and delegates, and build really cool application architectures. The front-end developer receives a page, and they add some interactivity to it, and they style it, and they make it beautiful with good CSS, but it's a different sort of approach to development. Now, Angular developers come from both. They come from back-end and front-end developer backgrounds, and that makes for an interesting clash in the middle end or the middle tier. So for almost anybody, even if you know JavaScript, you need to relearn JavaScript because we know it as a scripting language, and jQuery copied from Stack Overflow is not relevant experience for doing Angular development. So there's a lot of value in sort of really embracing JavaScript. And even if you've done JavaScript for 10 years, as I did before I really got into Angular, you're best to just wipe your mind of that and think that you're learning Python or Ruby or a language you've never learned and approaching it with that mindset, a real beginner's mind, and learning it sort of top to bottom. And most people do that by starting with like a book like JavaScript, The Good Parts by Douglas Crockford, because it really opens up your eyes and you get to sort of learn about the deeper, wonderful aspects of JavaScript. So learn software engineering. Now this, if you're a front-end developer and you've been working in the front end, I'm sure you're an excellent developer, excellent at HTML, excellent at CSS, but we're one order of magnitude up in the size of the code base. And anytime you go from one size code base to a larger code base, different principles apply. And so, things that were sort of interesting but maybe not essential before, like maybe design patterns or what's good code and all those kind of things, like really good code, becomes essential. And it's also the longevity of the code. It's going to last a lot longer, so the maintainability becomes probably the most important thing, writing code for other people to read in the future. The other thing is that you can actually do this now in the front end because you're moving enough into the front end, and Angular provides an architecture that decouples things enough that you can architect your code. Get alignment. Self-organizing teams are great if they organize the right way. So if you have an organization and you have, say, 20 Java developers who are all experienced, and you adopt Scrum, and you're working on an agile process, and they're self-organizing, and everything's working smoothly, and now you bring in Angular and JavaScript to that same team, they're not going to be able to self-organize effectively because they don't actually know what they're doing yet, and they're going to have different perspectives of how they're going to go about doing it. And so getting self-organized, I mean, they can get self-organized, but it's going to be a big effort. There's an educational effort. There's mistakes that are going to happen. Testing is a great example of that. Everybody tests differently, and if you have 4 people adopt test-driven development at the same time, and there's no alignment, and they don't really realize they need alignment, you're going to end up with half your tests are going to actually be a problem because they're too low level of a level, and they're really focused on implementation details. And now you have this team that's enthusiastically adopting test-driven development, and 2 months in, it's anytime anyone makes a change, half the tests are breaking, and their deadlines are slipping, and they throw out testing because it's a load of crap, and it was just a fad, and it never should have been adopted anyway. But the problem really is the tests are written the wrong way, they're not written at the same level, and they're too coupled to implementation details. There's a lot that goes into that, and if you have lots of people learning at the same time, they're not going to be aligned no matter how hard they try to self-organize, because they don't really know what they're trying to align on. There's a huge functional shift if you're moving to JavaScript, and learn to think functionally, at least somewhat. So transform your JSON via a functional approach. Underscore lodash or libraries that give JavaScript a little more of a functional flavor. They help significantly with that. And if you sort of, get your mind wrapped around that, it makes a huge difference. And so this is, if people have been thinking in objects, for the last 10 years, doing some good training on JavaScript practices, and functional ways of solving some problems will give them a much more powerful toolkit for doing their Angular development. Plan for all your changes. So what we see over and over, people moving to AngularJS are extremely excited because they get to get away from jQuery and that really complex jQuery selector hell that breaks everything every time they need to make a change. But it's also it's a fresh start, right? So Angular has great testing, so awesome. We're going to do TDD, right? That's awesome. And we're going to do frequent delivery. We're going to do agile. The problem is these are all extra things. So they're learning JavaScript, they're learning Angular, they're learning TDD, they're learning Agile, and those are each a significant undertaking in themselves. And so this really hits enterprises hard because you have 20 people who all need to climb this hill. And even if they're, as I said, they're doing Agile before with their known tool set that they've been doing for 10 years, this is wiping that slate clean. And so now they have to learn how to do Agile with this new tool set and with test-driven development. So, with sort of moving into Angular, your code can support your process if you sort of, come up with the right development process and the right source control process, and you really get the testing in there, the frequent delivery. And your process can support that, so how you're going to handle pull requests, how you're going to do code reviews. Getting your process and your technology working together can have them both help each other in the adoption process, but there's a significant sort of hurdle to climb there. So functional async with promises. So we're talking about Angular being functional. It's also asynchronous, which causes a lot of differences in programming style. And as you work on larger and larger code bases, handling that functional asynchronous call logic, program flow becomes really hairy. And promises provide an amazing solution for doing that. And you can do things like this, where you're going to get your data synchronously, and you get a promise, and then you can use that promise and then transform it. So we're using services and promises to set up a functional pipeline to transform data. And we can do that and read through this and understand this and reason about our code without pulling out our hair. And that's one of the things that ultimately you get with a cleaner control flow of your application, is that you can actually reason about your code. So I'm not going to go obviously into detail on this, but I just want to give an example. This is like promises in a functional asynchronous control flow that has a huge impact on how you can now start thinking about dividing up your code, creating modules, and now you're composing your application with functions from modules that have a pipeline of transformation for data that's coming back asynchronously, and you can do a lot of sort of wild things that are very easy to look at and understand once you've done them. Not sure what's going on there. So error handling with processes again, so you have this sort of control flow that's asynchronous, and you can have that chaining, so you can get your data, you can filter it asynchronously, you can then inject it into your scope, and you can handle errors, and often only one catch is necessary. So here we have asynchronous sort of activity happening in two different places, and it's not really affecting our control flow. It's still easy to read and reason about. Also, you can see that most of this doesn't look like Angular, right? So as you go through it, you see scope in one place, you see HTTP in one place, but you have a lot of services or functions from services that look just like regular JavaScript. All right, I'm just going to hold this up, and then it's going to magically change, so that's good. So lean promises. This is a sorry about the formatting, but this is sort of an interesting code snippet from a class that basically asks when is it okay to not catch errors? And this is a promise with a then, and it's returning some data. And the reason that there is no catch here is because there's a return, and as you're composing an application with services, abstracting up, if you're returning a promise, that means that the caller is responsible for handling the errors. And if you have error handling in your services at multiple levels, then you're going to really botch your control flow and not really be sure who's responsible for handling errors, and have a hard time finding things, where things are going wrong, because you don't have a hierarchy of responsibility. So you can have lower level libraries that essentially return up promises and do not handle the error, because it's really the caller's sort of responsibility to do that. So there's interesting sort of issues that arise as you build larger and larger apps with more and more modules and services that are coordinating in the sort of creation of your solution. Another key thing in large-scale Angular apps is managing state. One of the things that the Ember community brings up a lot is that Angular state management is sort of idiotic. That's the out-of-the-box state management. The Angular team's actually fairly embarrassed by it, so in Angular 1.2 they removed it from the core. And almost everyone I know that's been working with Angular for a while uses UI Router from the Angular UI team, which provides a great sort of, almost like a state machine for declaring state in your app and coordinating the flow of logic and basically the flow of logic through your app for different views at different levels. And so it's a significant architectural underpinning, and you can do some really interesting things with it in terms of even sort of lazy loading and setting up different sort of business logic to control authorization and pretty much anything you want. All right, so that was the talk. So to recap, Enterprise Angular is about building very large Angular apps. I would say that this is still being learned in the industry, and the big shift early on is moving away from Angular as an architecture to building architectures on top of Angular, and those best practices are emerging. And so how you go about using Angular and composing your business logic and bringing it all together and working with other frameworks that are emerging. So one of the big areas where Angular falls short is in terms of event management, and then larger complex event management sort of that would be required in an enterprise application. So that's starting to come out, and there's third-party libraries and different ways of approaching that. So Angular has its sort of broadcast mechanism, which is fairly simple and has some edge cases that it just breaks down on. Organizationally, that's a key thing. If you're building large Angular apps, it means that you already usually have a large team in place, and you have to pre-consider some of the large-scale sort of design decisions that you're going to be using in your Angular app. And code-wise, these practices are emerging. There hasn't been anybody that I've met that's built a large Angular app and then said, oh no, we hit a wall and things are broken. And so it has a lot of room to go up. I don't think there's a lot to be worried about in terms of single-page apps. And yeah, that pretty much covers it. Are there any questions?